Hello. Nice to meet you all. So I am Christopher Cartland, and I'm super excited to be here today. How many of you are in middle school? If you put your hands up. Awesome, excellent. So I'm really excited to be here because that's the first time I wrote code, and so it's a great time to share all the things I do. I love talking about code. You'll see that I usually do this a lot, even for my work today. So it's great to be here with all of you. Middle school is great because I started trying to learn a bunch of new things. I tried to do front handsprings, I tried to learn photography, and I tried to write code. But I actually failed to do all of these very well the first time, and I'll talk a little bit about the failures. And throughout this short talk, I want to bring you from when I was in your shoes in middle school to where I am today. To make it a little more interesting, I'm going to talk about some interesting projects that I've done at each of these different stages. So starting with middle school, I first got started programming because I watched TV, and there was this program called Tech TV that I watched a lot. And one day, this 16-year-old was on the show because he had written a book called Game Programming for Teens. And he wrote it when he was 13 years old. He was on the show when he was 16. And I thought, that's amazing. If he's able to make this book about programming, maybe I can learn it too. So I asked my parents for a copy of the book, and they were very nice, and they got it for me. And that's how I first got started programming. In the book, you make a game. This is like a space game where you fly a ship around and things come down and you shoot at them. But once you make the game by following the book, you can change all of the parts of the game yourself. Since you see how they work, you can change the graphics, you can make it run faster or slower, or make an entirely new game yourself. And so this is a lot of fun because I was in control, because I had seen how everything worked. In middle school, I also went on spring break later that year, and I was at my grandmother's house in Florida and spent a lot of time on the beach and was enjoying the sand and the water. But we also, since it was a whole week, and this is before cell phones, there was a lot of free time in the house. And so I was looking around the house for interesting things, and I found this book called Magic Eye. Has anyone seen this before? Have you seen? A couple hands went up? Yep, okay. So I didn't know if this was still a popular thing, but these are images that are illusions that create 3D images off of just basic paper. And as I thought these were really cool, and I was looking at them a lot, but after a while I started wondering, how do they work? How is it that a flat piece of paper can create a 3D illusion? So you won't be able to see this right now because they only are visible when they're on pieces of paper or screens that are about 10 inches wide. So if you want to try and look at these after the talk, I actually have this book and some other images that you can try out. So just keep that in mind if you're interested. So I was looking at these and trying to figure out, how are they able to make the flat image become 3D through this illusion? And I looked at it closely. I thought, I think a computer must be making these images. There's no way that this is done by someone drawing it themselves. And as I looked into it more closely, I realized that there's this repeating pattern coming from left to right. It looks like the same kind of stuff all the way across the screen. And this reminded me of something else. I played baseball, and when I spent a lot of time in the dugout, so I wasn't always on the field, but when I was in the dugout, you would look through a chain link fence like this. And this has a repeating pattern similar to the Magic Eye. And normally when you look at the fence, like if you look at that middle link right there, both of your eyes are looking at the same point on that fence. Now, if you're sitting in the dugout and watching the actual baseball game that's happening on the other side, you may notice that the images, the things you see kind of like, there's like double vision. don't know if you've ever looked through a fence, or another thing you can do is you can hold up your fingers to your eyes really close so you can't focus it, and you can see a middle finger, kind of as a finger in the middle that's floating in the air, if you've ever seen that before. So that's kind of what's happening here if you're looking through the chain link fence. And sometimes those two images line up, but not in the place that they originally started. And when that happens, your eyes are actually looking at two different points at the fence, but you think you're looking at just one. And this actually creates this weird illusion that the fence is somewhere different than it really is. And I've actually bumped my head into the fence before because I thought that it was farther away, and really it was right in front of my face. So this is actually the same technique, that, the same, I guess, brain trick that is going into the 3D images that are in the Magic Eye books. And they're called Autostereograms. So I wanted to try and see if I could make these images myself. And so my goal is to somehow have a 3D image pop out that looks like this in 3 dimensions, like off of the piece of paper. So I first needed to have some sort of colorful background that's going to be the repeating pattern. To do that, I'm going to start with a photo that I took. This is in Chefchaouen in Morocco. It's a beautiful city where the walls are made of blue. I'm going to use this as the pattern in the image. So the first thing I did, and this is in middle school at my grandmother's house, was figure out, I think that this is just caused by creating a pattern. So I'm going to take these colors and squash it horizontally and then just repeat it a bunch of times across the screen. It turns out that if you do this, you can do the trick of seeing not a 3D image, but at least it's that illusion like the chain link fence that I saw while playing baseball. So when I did this, I was able to do the illusion. I thought, wow, I think this is going to work. I still don't know how to make a 3D image, but I think that I'm on the right track. I'm getting closer here. And so I then spent a lot of time trying different ways of tweaking the image to make a 3D image pop out, which would have the depth that I wanted. And I failed at this so many times. It took me so many tries where it didn't work, and sometimes I thought I was getting it right, but it turned out I just didn't know how to view the images correctly, and so it wasn't actually doing what I wanted. But eventually I was able to create an image like an autostereogram that looks like the ones I saw in the book. To show you how it works, I've taken that same image I created on the right, and I'm just moving it back and forth really quickly. So this is actually the same thing. And when you move it back and forth really quickly, it looks like most of the image isn't moving at all. So like the top and the bottom. And that's because it's just a repeating pattern. But there's some places in the middle that look like they're moving back and forth a little bit. And that's how these autostereograms work. You adjust the position of the pattern just a little bit in the middle, and it ends up creating the 3D illusion for your brain. So you can see that those little pieces look like they're about the same shape as the black and white image on the bottom left. The algorithm for this was actually fairly simple. It just took me a long time to figure out. And this was my first major programming project, and I didn't know much about code. I only knew 3 things. The first is that I knew how to do a loop. And a loop is just a way of running a piece of code many times, because I needed to do this piece of code on every dot on the screen, every pixel. And I learned this from the programming book that made video games. I also needed to be able to copy and paste the colors from one place to another in order to make the repeating pattern. So this is how you copy something in the programming language Blitz Basic that I was using at the time. And this is how you paste. The hardest part about this was not really the programming itself, but it was figuring out how to make the depth part, how to make the 3D part work. This is what I failed to do so many times, and eventually, after a lot of help from people looking at the images and thinking about it, I was able to get something that worked. So that was my middle school project for creating autostereograms. In high school, I was mostly focused on having fun, and I am from a small town called Templeton. It's about 3 hours south of here on the same freeway next to us, 101. Even though it's a small town, we were lucky enough to have a computer science class. and I thought it'd be a lot of fun to take this computer science class as soon as I got to school. So I signed up, and I went to the class, and I hated it. I really didn't like this class. The teacher and I did not get along. I thought she was mean, and I don't think she liked me very much because I was just trying to have fun. And so that was a really bad experience, and it was the first time I was going to do computer science, and I thought I was going to learn what real programmers do, and I decided that if people who program are like this person who was trying to teach me, I didn't want to do computer science anymore. So I decided at that point, I'm going to focus on other things. So I focused on sports. This is a photo of me playing soccer. In middle school, I started learning to do handsprings, but I wasn't very good at it. I kept falling over all the time. But I kept working on it, and with the encouragement of my teammates, got very good at throwing a soccer ball really far. And it turns out that when you do a front handspring, you can get a lot of momentum to throw the ball ahead of everyone, and we scored a couple goals this way, which was great. I did a little bit of kind of paying attention to technology. Who uses websites on a phone or on a computer or tablet, or you've heard of a website? Okay. So it turns out that they're using HTML to show the image here. So this is a simple table in HTML. On the left, it creates the stuff you see on the right. So just to kind of give an example, we have the header information, and then below that there's some table data inside of it. So I was learning a little bit about how web pages work, just on the side, but it wasn't really a major project. I also had a lot of fun in high school by doing pranks. So this is a photo I took of some friends who pranked me. They put a bunch of plastic forks in my front lawn, and I had to go clean it up. And we thought this was so funny that we decided to kind of escalate this a little bit and do this prank on our entire high school. So we put forks in the front line of the entire high school. It's a very big field. We covered the whole thing. This is bigger than a football field. And we thought this was a great prank. As seniors graduating, we were very proud of ourselves. I thought it was a good prank because I thought it was funny. I thought it was noticeable. And I also thought it was reversible. Like, I was going to be able to, you can undo this just by cleaning up all the forks, and there's no permanent damage. Because I wanted to have all the fun of pranks without actually causing any real harm. But as I was thinking about pranks, I realized that I knew how to make a simple web page that looked like my grade report. And I thought, wouldn't it be funny if I made a fake grade report where I changed the letters so that it looked like I failed all of my classes. And I printed out this fake web page, and I thought, this would be great. I'm going to show this around. It turned out that this was actually a really bad idea. You should not do this, because it ended up hurting a lot of people in ways that I didn't expect, and it was a lot of people I cared about. So my parents were very upset by this. The school was put under a lot of pressure and a lot of stress to figure out what had gone wrong. They thought that someone had hacked their system. And even though I thought I was doing, this was like a reversible prank, something you can undo, because I didn't actually have access to change my grades. I was just printing this fake page. Still caused a lot of problem. So I regret doing this. Please don't do this. But the lesson I learned here is that as you do things, even if you have the best intentions, you may end up hurting people along the way. And so you should really be careful and make sure that everything you do is good at every step. So that was my high school experience of having a lot of fun and learning things on the Central Coast of California. As I came to college, I came to the Bay Area to attend the University of California at Berkeley. And since I had such a bad computer science experience in high school, I decided to do physics. And so my major was engineering physics. And as a physics major, I learned very quickly about a really cool team at UC Berkeley called CalSol, which is the UC Berkeley solar vehicle team. And this team designs, builds, tests, and races full-size vehicles that are powered by the sun. And they have a big race that goes all the way across the continent of Australia. For those of you who don't know, that's 3,000 kilometers from the north coast to the south coast, and it's actually about the same size as the United States, so it's a really long way. You can imagine driving across the whole country on just solar power, and there's also a race that the team has done in the United States as well. This is a great project for teamwork because I showed up, I think everyone else showed up, and no one knew how to build a solar-powered car. And so we had to figure this out all on our own, just by helping each other out and seeing where we could contribute. When I showed up, the first thing that I worked on was building some of the steering system. So I was a physics major. I wanted to work on how the car actually is physically built. So I wanted to design how some of the components work that control the steering, like which way the car goes. To do this, I actually had to do some math. And at this point, I didn't know anything about cars, but I knew a little bit about trigonometry and a little bit about geometry. And so I did some math to figure out how long some of the pieces needed to be in the car. But since we had to design the car, we wanted to try a lot of different options. So you'd have to do this math many, many times. So I ended up writing a small program that did this calculation for me so that I only had to do it once instead of doing it hundreds and hundreds of times, maybe thousands of times. That math from that program is how we determined how long to make that horizontal piece of metal. And once we decided how to do that, I actually got to go build some of this myself in the machine shop at Berkeley, which was really cool to actually see how you'd make something out of metal like this. The next thing I worked on was shifting a little more into electronics. I see that at the event here today, you're working with LEDs. So I had to do a similar thing to make the turn signals work on the solar vehicle, which means that I had to physically wire it up so that when you flip a switch, it's going to control the left light, the right light, or both. But when you need both lights to turn on in order to enable hazard lights, and those are important when the car breaks down and you're stuck on the side of the road. And unfortunately, our car broke down all the time. So we needed to make sure that the hazard lights worked correctly. Once we had the physical controls, though, you still needed some software to actually tell the lights how to behave. This is the first time I learned about the C programming language, very famous language that's used at a lot of low-level, efficient architectures. And I learned a lot of things here that I'd never seen before. I learned about AND mathematic operators. I learned about OR mathematic operators. And I learned about bitwise operations, which were how to do zeros and ones and make that work in my code. And when I was able to do this, this is actually a similar piece of code to how we figured out how to make the lights work on the car. I really got into the solar car project. CalSol was great. I kept doing more and more and more, and eventually I became the team lead and helped bring the team to Australia for the first time. So that's me on the left wearing a really cool hat, which it protects me from the Australian sun. And on the right, you can see us on the side of the very, very long highway that has, I think, exactly one turn between the north coast and the south coast. And we drove the solar car along that. At night, we would camp on the side of the road because we don't know where we're going to end up at the end of the day. And to get a little bit more sunlight, we would actually tip the solar cells and point it towards the sun. So we get a little bit more energy at the end. The roads were dangerous because there's only one road for the whole country throughout the middle. And they had these road trains, which are kind of like semi-trucks that you might see here in the United States, but they can be 4 times as long. You can see this one is approaching us. And it's quite scary if you see this coming and you're driving in this tiny little lightweight, efficient solar vehicle. And so the drivers had to be very careful when they were driving to make sure that they were safe. And the team actually designed the aerodynamics of the car to take account for wind from the side to make sure that the drivers would remain in control. Sometimes we saw this come down the house, like down this road. This was a house. And we heard this in the radio before we saw it, and we didn't believe them because someone says, like, hey, there's a house coming, get off the road. And we say, what? Can you say that again? And this time it was much more loud, and they said, there is a house coming, get off the road. And sure enough, we saw a house coming down the road, and we all had to pull off the side to get out of the way, because there's no way that something that wide is going to let any vehicles pass. So that was the weirdest thing we saw throughout the trip. We were very proud to represent both the United States and UC Berkeley with our team, and I got to accept an award on behalf of the team when we arrived at the finish line in Adelaide, Australia. This was so cool that I actually ended up switching my major to Electrical Engineering and Computer Science, or EECS, which is the engineering major at Berkeley. And so I had come from my high school experience where I really didn't want to do computer science, to college, where my teammates showed me all of the cool things that you can do with software. And I decided, you know what, these people are amazing. I want to be around people like this, and I want to write code. The team has done really well since I graduated. I got to visit them and take photos 2 years ago at a race in Texas. These were the new team leads as they accepted their first place trophy for winning the race. And that's another teammate in the background who's just having fun. I was able to take photos and actually be there at the finish line when they crossed with the checkered flag and won the race. So this is a really proud moment for me because the team was doing much better than when I was on it. And it's amazing to see where they've taken the team after I left. That's part of the reason I'm excited to be here with you today, is to see what you are going to build next. Because I know that people who are younger than me who are getting started with technology can do even more cool things than what I was able to do at the time. And that was my college experience with CalSol, the solar vehicle team. I want to talk a little bit about work and what I actually do now and how code is involved in my current life. I've actually had 3 jobs at Google. The first one was an internship, which is like a job except that you're still in school, and I did it over the summer. And then the next 2 jobs were, one was an engineering role where I wrote code, and then the other one, the one I have right now, is an advocacy role where I work on strategy and figure out what code should you write. My internship was a lot of fun, probably too much fun. This is a trip we went on to ride ATVs one weekend. And while I was a product manager, I actually got to launch a product and write a blog post about that during my internship. And so this was all great, but unfortunately, I did not get to return with that job. So even after all this, I was very disappointed because I wanted to return to Google in this job where all my friends were. Fortunately, a friend of mine, that's Joanna, told me about this cool organization called DevRel. And she said, you might be really good in this, and I think you should check it out. So I went through the interviews, and fortunately, I got the job. This was great. I had a choice between software engineering, where I'd write code, and developer relations, or DevRel. And I ended up picking developer relations because I knew that I'd get to work with more people on how they build software and what they're trying to use it for. So to show you some of the things I've actually got to do, this was the launch of Android TV. So who watches TV shows? How about watches movies, listens to music, plays video games? Oh, well, he's excited about video games, yes. So one thing I got to do is actually work with the companies that make apps that play movies, video games, TV shows, and bring those to a new type of device. So you can use the same technology that you use to build apps on your phone, and you can bring that to TVs. And so my job is to talk about how does that code work, how should you build it, and how do you make things work really well for these new experiences. This is also cool because I learned about programming from watching TV. And so it was cool to be able to now use my software experience to make TV better. Just last week, Google hosted an event called Google I/O. It's a conference where we talk about code and a lot of different technology. This is actually hosted just down the street at Shoreline Amphitheater. Since I worked with music apps, I got to work with them on some of the new car experiences. So there's going to be new vehicles that people will be able to buy that actually have Android built into the car. And so you can build the same music experience in that vehicle. So I've worked with Pandora, iHeartRadio, Spotify, and many other companies to actually bring their music apps to these new vehicles and devices. So it's really cool to get to see all this stuff before it's released, and then also be able to help design how it's made. I don't just design things for new products, but sometimes or not just new hardware, but sometimes it's just new technology. How many people have an Android phone? A lot of people, yeah. So if you use Pandora to listen to music, you can actually use the clock app, the Google Clock app, to set an alarm that plays Pandora music. And I designed the software integration that connects those two together. So this is actually how the Google Clock app and the Pandora app communicate. And the only way they can do that is with software. So this is really great. There's a blog post that Pandora posted about the engineering integration, and they were nice enough to mention my name in the credits. In my job, I also get to not just write code or design it, but I also get to publish it. So this is an app that I made last year with a small team. We built an Android app, a web app, and a server that shows people outside of the company how to bring multiple Google technologies together. So this is cool because the code this is different than code that is meant to be run and used all the time. This is code that's actually meant to be read. So when I write code, other people actually read it to learn from it. And so I really like that part of my role, because it's not just that it works, but that it also helps teach and show people how technology is able to accomplish whatever you're trying to do. Apart from publishing code, I've also published some blog posts and some videos that explain how this code works. This is an example from a project I actually did for the Solar Car team, CalSol, because after I left, they needed to elect new leaders. So I wrote a voting piece of software that allows you to vote using Google Forms and then use Google Apps Script to calculate who won using this algorithm called instant runoff or ranked choice voting. So that was cool that I got to actually do something I had done in college and talk about it at my current job because I was talking about how software works. Part of my job is also just to understand how, what type of innovation there is out there, like what's new. So on the left-hand side, this is a screenshot from my phone, again, just down the street at Google I/O last week, where I'm testing an augmented reality experience, where I'm holding up my phone and pointing it around the venue. And my phone is showing me, it's putting little pictures on the screen of where things are. So most importantly, I could find out where food is because it would put a food icon on the screen. On the top right is a demonstration where it's showing image recognition technology. So you can see me doing a cool dance. And on the left, Google is actually trying to find pictures from the internet that look similar to the pose that I'm making. And this together is able to make an animation that's fun, because it's showing a silly dance, but it's also demonstrating a really cool piece of technology, which is how it's able to process images and recognize the position that you're standing in. One thing I didn't realize before I did all these different software projects is how much people are at the center of writing code. I originally thought that code was about just the computers and the devices and the things you write, but really you're building software with people, for people, and a lot of that involves talking with others and figuring out how you can make something really cool. This is me, again, last week. This is all recent photos here, where I'm at an office hours table where people can come up and ask me questions about a huge variety of Google technology and how it can help them accomplish their goals. And I really like doing this because I get to talk with people about code, show how it can be cool, and also think about how we can build new things. This is our global team of people with my job, developer advocate. And we're based in places all around the world so that we can work with the top app and website creators to bring their experiences to you in the technology you use. We help them understand what Google offers so that they can focus on building really cool things with all the work that we have created. So I've talked about 4 different projects that or stages of my life that I'm kind of proud of. I really did fail, though, in all of these. So when I tried to make the Autostereogram images, the Magic Eye images, I failed so many times to get that depth to work. And it wasn't until I had help from my dad to kind of look at the images with me and encourage me that I was able to figure that out. I also tried doing handsprings in middle school, couldn't do that. But with encouragement of teammates, I got much better and was able to use those in our varsity soccer games. In high school, I decided not to do code because I had a really bad experience. But when I went to college, the CalSol Solar Car team, the teammates really showed me all the things that code is good for, and that changed my mind and made me decide that I like code and I like electrical engineering again. And then when I was trying to actually have a job, I got rejected from the internship, or the full-time job that the internship was based on. And that was really disappointing, but thanks to friends that I knew, they were able to give suggestions on other jobs that I could look for in order to continue that path. And as another example of how many times you might fail something before you succeed, here's a photo I took of a friend controlling lightning. He's not actually controlling lightning. So what happened is that he stood there in the rain, pretending to control lightning, and I kept taking photos again and again and again. And I took so many photos, and it failed so many times, and he was getting colder and colder and wetter, but eventually lightning struck. So if I want to leave you with something, I want to highlight that I think you should try to enjoy learning from your failure. I think that the things that I am good at are the things that I have failed the most. So, thank you very much, and I'm happy to take any questions. Say again? I got apps, something with games?
Have you ever worked with Epic Games, like the ones who create like Fortnite and all that?
So some people on my team focus on games all the time, and so they, yes, they're aware of that company and do various things with it. Yeah.
Can you give me a discount?
Gonna give you a discount. Sorry, I can't give a discount, but maybe you can ask someone and see if they know anything.
All right.
Yeah.
You said you do things on the car that make it more like an Android?
Yeah.
What are those things, and are you planning on creating a video game system in the back of the car?
That's a great question. So we have, I don't know if you drive yet, but when you get a car, hopefully there will be options for you that have Android built in. And they're using all the technology that Android has on your phone, so you can update apps. Currently, we haven't built any games for the car yet, but I like how you mentioned the back of the car, because we don't want to put games where the driver is distracted, but that's a great idea to put them in the back. I like that idea.
My parents actually get in the back of our own van. My parents actually used to make the effort to install putting Nintendo in the back of the car so my mom and I can just play on the TV wall.
That's great. So your parents helped you get a Nintendo in the back of the car. Yeah, that's awesome. Yeah, no, I think if we should get some cars with displays in the back, and that sounds, I'd love that. Yeah, let's put games there. Thank you for that. Thank you for the request.
Since you work on developer relations, what has been like the most fun project you've worked on?
Yeah, most fun on developer relations.
Like a company you worked with or something?
Companies I've worked with. Ooh, I have to pick favorites now. No, I really do. We work with a lot of great companies, and I mean, I mentioned some of them. I worked on TVs, I've worked on cars, I've worked on watches, I've worked on wireless headphones that have the Google Assistant built in, so you can talk to them. I think I'm missing some other major ones. Yeah, we've done work with machine learning. So I mentioned some of the companies, but yeah, these are all fun projects in different ways. And yeah, it's really cool that I get to see a lot of different technology.
I assume since you had like the good grades and you had to prank your parents to make you believe that you had all Fs, like how did you manage your time, to like succeed, in getting into like a prestigious school like, UC Berkeley and like succeeding? Like what steps did you take, as a freshman all the way to your senior year?
Yeah, I think that I really focused on making sure, I tried to learn everything I could. I mean, I was always very curious. And so sometimes, depending on the class, that was harder. But I focused on learning it and making sure I understood things, and then hoped that I would then be able to get a good grade after that. I actually, high school was the first time that I went to a school that had grades. So all up through middle school, I went to a Montessori school and then a Santa Lucia Middle School in Templeton. And they didn't give you like a score. They would just tell you like, oh, here are things you can work on. And so my whole life has been around trying to do better, and then hoping that I am able to get the grades to go along with that. One thing I want to mention too is that I made a bunch of custom images that are the Autostereograms. So if you're interested in trying to learn how to view them, I've made these ones myself on a piece of paper, and there should be enough for everyone to take one home at the end of the day if you want to practice with it at home and show it off.
I have a question about the solar car. Was it only working when the sun was shining on it, or did you have some kind of way to trap the energy and store it?
Yeah, so the question is about whether the solar car only worked when the sun was shining on it, or whether there was a way to trap that energy. So we did have a battery pack in the car. Because you go into the shade for a moment, and you wouldn't be able to go anymore. So the batteries were important. We also had software that analyzed the energy usage in the car, so that we could try and figure out whether we should be depleting the battery pack, like using more power in order to go faster, or whether we should be storing more for coming up. So for example, if you're going up a hill, you're going to consume a lot more energy. And if you're going downhill, you're going to gain it. So we had some strategies, but honestly, the current team at UC Berkeley is way better at strategy, and they manage that battery much better than we did.
About the solar car, did you have like generators on the wheels?
Did I have generators on the wheels? Great question. Yes. So we actually, the motor did two things. One of them, if you ran it regularly, ran it forward, would drive the car forward. But you could put on a regenerative braking mode where it would basically run the motor backwards. It didn't actually run it backwards, but it flipped the circuitry around. And it would actually, instead of putting energy into the wheels, it would retrieve energy out of it. So that means that if you're going downhill and you want to slow down, you can actually get some of that energy back and recharge the battery a little bit. Yeah. Did we see a lot of spiders in Australia? We saw, we did see spiders in Australia. We also saw a lot of other weird creatures. And actually the most disturbing one is on the side of the road, it kind of looks like Mars. There's like red dirt everywhere. And we'd see these like giant towers of dirt created by some insect or creature. And then we'd see giant holes created by some other creature, but we didn't see the actual creature. And that was what made us most afraid. Because we didn't know what was making all these things and like what was living and what was going to come out at night. Yeah, interesting. Yeah.
So let's just say that there's like a PC game, right? Like Fortnite originally.
Mm-hmm.
And how did you guys like transfer like the PC game into mobile? Because there's different platforms. Like how do you guys transfer one app or program into a different platform?
Great question.
What steps do you take? Like what do you guys have to take into consideration when you're doing that to keep the same gameplay?
Yeah, that's a great question.
And servers too.
Yep, that's right. So there's a couple things to that. One of them is like the game itself, which is often written in something that is either C or C++, and that needs to be able to run in different environments. So like Android and actually iOS as well support the ability to run like they call it native code on their platforms. So you can bring the game over that way. One thing that's also interesting is that when you change to a new device, you need to think about how the user interacts with it. Like, do they have a game controller, or is it a touch screen? Or do you have an accelerometer where you can rotate the device? And there's a lot of, or are you controlling it by voice? And there's a lot of new different input methods you have to think about. So I think that there's the two parts of it are you need to make sure it still runs on the new platform. Like, do you have to build it from scratch, or can you copy it and just run it on the new platform? And then what is the user experience like? Like, how can you control it? And what do you need to make any modifications for that? And yeah, so there is a team that works on that. Servers.
Like, you know, sometimes, like, for example, when two parties, like, one party could be playing on, like, another platform. Like, how do you guys, like...
Yeah, I see. Yeah, sorry. I missed the question about servers the first time. Thank you for reminding me. So the server is the part that is not running on the device. So it's not your phone. It's not the console. And that is running somewhere else, and you can host code there. And this is how you usually host games with multiple players. This actually can be used. You can have one server that works with many different types of devices because they all communicate over the internet. And as long as they use the same language or same protocol for communicating over the internet, you can have many different devices all talking to the same server. One thing I actually have heard, though, for games, though, is that you sometimes want to segment your users, because if someone is playing with a keyboard and mouse and someone else is playing with a touch screen, you may want to have them play against people who have the same input methods. Otherwise, things can be unbalanced because it's too easy to do certain things in one game. But so you can choose, basically, either to do the same or separate the users with different servers. Yeah, thanks. That's a great question.
Yep.
I'm not sure if you really worked on it much, but for Project Stadia, I'm not sure if that's pronounced. Do you think it's like a thing that's really going to take off, like running stuff off device?
So if you ask about Project Stadia, and is that
Yeah.
something that's going to take off? So I mean, I think I don't work directly on that, and so I don't actually know where it's going to go. It's hard to predict the future, but I do think it's very exciting because it's able to do high-resolution gaming, not running on device, and it still looks amazing. And I don't know how that's going to work as more and more people play it, and like we'll have to see whether people like that. But I did get to try it at Google I/O just down the street last week, and I was surprised at how good it was. It was really, really cool. And so I'm looking forward to being able to try it more and see where the future goes.
Do you have a question?
All right, so tell us about, while you're working at Google, how do you keep abreast of all the new technologies that are coming? What are the opportunities? Yeah. So that's one question. And the second question would be, given at your role, can you wow these kids with a Z-Wiz technology that would be coming, that wowed you, but we don't know about?
Ooh, yeah, what do I know? Yeah. So, I mean, the way I'm fortunate enough to be surrounded by like a lot of amazing people at Google. I mean, we are right next to Google right now. And a lot of people are keeping track of various things. So you can just talk to people and say, like, what's interesting? What do you know? There's also a lot of, press that actually covers tech and it is covering a lot of new things. And so surprisingly, I learn a lot about things just because of what other people are talking about. What's a new technology that I know about that you don't, that I'm allowed to say? What is there? I guess one thing that was announced last week that I was amazed by is some of Google's artificial intelligence and ability to do voice recognition on the device, which means most voice recognition today goes to a server, and we've talked about servers in games, but when you talk to the phone, usually that has to go to somewhere which processes that data and figures out what you said and then reads it back to you. Google announced last week that they were able to do this completely offline in airplane mode on a phone, which is amazing from like a privacy perspective and like the ability, and it's also super fast. So like you can talk to the phone and it immediately understands what you said because it doesn't need the internet. So I'm really excited to see where that's going to go because I think that voice detection offline is going to make it much easier for us to interact with everything we do in a lot of cool ways.
All right, does anyone else have any other questions? Okay, one more.
How many things do you know that we don't yet?
How many things do I know that you don't? Well, a lot, but I don't know how many of them are useful. So I probably, I probably know about a lot of things, and I know a lot of useless knowledge. So, I try to, I try to share the things I think are most interesting or most valuable. And if you have any more questions, I'm happy to chat and explore.
All right, can we give Christopher a big round of applause? Thank you so much for being here. Do you have any closing thoughts? Do you have any words of advice for middle schoolers entering this exciting field?
I think that try and find something that is interesting to you. You're going to have way more fun if it's interesting. I think that software can help with most things, not everything, but even if you're not interested in software itself, you might think about how code can help you accomplish whatever you're trying to achieve. Have fun with it.
All right, well, thank you, Christopher. All right, everyone, we can give one more round of applause. That was a very awesome talk.
Thank you.